Your developer or organization account allows you access to a variety of tools which you can use to interact with the ArcGIS platform. And when I say tool, I mean any type of product, application, or functionality that you can use as part of your development workflow to prepare maps, layers, and data for an application. For example, you can use ArcGIS Online for administration and data management. And for maps and scenes, you have Map Viewer and Scene Viewer, where you can create, explore, and share a web map or a web scene, depending on if your application is 2D or 3D. And for styling, you also have the Vector Tile Style Editor. I want to focus on these three tools for this talk. But before I get into them, I want to step back and go over a couple of key terms. The first two are related. These are web maps and web scenes. And essentially they are a map or a scene which are stored as JSON objects and contain settings for the basemap layer, data layers, and are stored in the platform as an item which can be accessed with a unique item ID. And for web map, these are stored as JSON objects according to the web map specification, and for web scenes, according to the web scene specification. And I also want to go over the term operational layer because you will see this a couple times if you look at a JSON object of a web map, for instance. And it refers to the layer that references geographic data from a file or a service and is used to visualize the data in a map or a scene. Again, the Vector Tile Style Editor is used to create custom basemap styles. And for Map Viewer and Scene Viewer, these are where you create a web map or web scene and also perform data visualization. In Map Viewer, you can also perform spatial analysis, but spatial analysis is another topic that I won't cover here. A typical workflow is that you create an item, so this could be your vector tile layer, you save it in the platform, which creates a unique item ID, and then you access it from your application. I want to step you through this workflow by going to the base maps first. And this is because when I typically create a mapping application, I begin with the base map because it sets the geographic and visual context for my application. There are different ways you can access a basemap. You can either reference its basemap enumeration and set it to the basemap property if you are using the JavaScript API, for example, or if you're using a Mapbox, or if you're creating a Mapbox application in another example, you can reference the style URL. There are 25 basemap enumerations available to you, and these range from imagery and topographic. Or if you're creating, say, a routing application, you can use the streets basemap layer. And there are also more stylized basemap enumerations like the modern antique map. But what if none of these basemaps are quite right for your application, or maybe you like the topographic basemap layer but don't necessarily like the color scheme? Well, this is where the Vector Tile Style Editor comes in, where you can interactively create, update, and save basemap layer styles. You can style individual layers such as land, water, roads, and buildings, and then save them. So let's go through this workflow by going to the developer dashboard. I'll create a new vector tile layer by going to Layers, Create Data, New Vector Basemap Layer Style, and this will kick me over to the editor. I'll choose the topographic map to start with, and in the quick edit I can randomize the color scheme and maybe change the water here to a deeper blue and maybe to make this a little less pink. Alright, I'm happy with that style. I'm going to save it, and I'll just copy a base map, and then I will just set it as public. Alright, once that style is saved, I'll be able to find its item ID in my dashboard. Let me refresh my dashboard page and go to the item page of my basemap layer. I'm going to copy its item ID, but I can also find its style URL and also the entire JSON structure as well if I wanted to just incorporate that into my application. Alright, so I have this application here that I scaffolded out using the JavaScript API, and right now it just displays the topographic base map layer. I want to pull in that vector tile layer that we created, so I will reference the module for vector tile layer and then also the base map because I'm going to add this as a base map. I'm going to use a snippet that's available in Visual Studio Code, which I will link to in the resources, and place my item ID. Next, I will create a new base map, and there we go. And then update my map so that we use the base map that I created. Great. So when I run my application, I will get that vector tile layer. So I went over the typical workflow where you create an item, you store it in the platform, and then you access it. Next, I want to go to the map viewer. Because the map viewer is where I can create web maps and pull in that base map layer that I created and use it as the foundation for my map. And I can also use map viewer to explore the data in ArcGIS Online and Living Atlas and display data from feature services, vector tile services, and other services as well. And just as a refresher as to what a web map exactly is, I have a web map of LA Parks and Trails, and to my right, this is the entire JSON object of this map. So you can see all the layers that comprise the web map, for example, the boundary layer, the parks and open space layer, which are these polygons right here. And if I go all the way down, I can also find the spatial reference. Anything that comprises a map, it will be in this JSON object. Why use a web map? I like using web maps because they're pretty easily accessible. You can create a web map in not a lot of time, and they're also configurable. So if I go back to this web map, I didn't have to use any code. I could configure the pop-ups in Map Viewer itself. And any layer changes that I want to make, say layer stylings, it will be dynamically updated in my application as well. I want to showcase this by displaying a web map that I have already created. This web map that I have created contains a bunch of different layers. I have a smoke forecast, which shows the current smoke forecast for current wildfires that are in the area. But I also have the fire incidents in the United States that are happening right now. And I also have a feature layer of Oregon counties. And they have some demographic information, for instance, how many people per county have taken an asthma medication. This is my item ID, where it starts with the 8A. It's right after web map. I'm going to copy my item ID, and I will show you how little code there is in implementing a web map in your application. I have the same feature layers loaded in this application that I scaffolded out with JavaScript. The difference is that there are added as individual feature layers, so current wildfires, smoke projection, and counties. I will delete all of this code and instead use my Visual Studio Code snippet to create a web map and insert the item ID. When I refresh my application, I will get that web map loaded in. And notice I didn't configure any pop-ups, but if I click on a county, for instance, I will get a pop-up with that demographic information or the smoke forecast. Now this is fine, but I want to make this map a little more customized. And I can do this by pulling in that base map style that we had created earlier. And I also want to visualize the data of my Oregon counties a little bit more so we can make the map tell a better story. To do that, I'll go back to my web map and I will click base map, topographic map. I will just hide that for now and add my vector tile layer and use as the base map. Okay. Okay. I'm also going to turn back on the wildfire incidents and smoke forecast and save my map. So as that saves, I'll be able to refresh my application and see that new base map style that we edited. Next, let's visualize the data. Now, if I already knew how I wanted to visualize my data, I could easily do any type of data-driven visualization. This includes unique types, class breaks, visual variables, time, and I could go to an example and grab any of the code snippets that are there. However, I'm not too sure what the best way to visualize my data is, so this is what I think is strength of the map viewer, that I can actually go in and play around with dot density or predominance and get a full representation of how the data looks. I will click Show Properties and edit layer style. I'm going to choose Field, and we're going to do asthma medication because as smoke permeates through these counties, people with underlying health conditions are the most sensitive to smoke particulate in the air. Now, the way it's rendered right now counts in amount size. I can't really tell the distribution. There are a lot of people in the Portland area who take asthma medication as compared to, say, in this county here, but I'm not really understanding the full picture. Let's try dot density. Again, we see that in Eugene and in, of course, Portland and in Hillsborough, for instance, there are more people who take asthma medication as compared to some of these other counties, but I want to be able to normalize the data so that we actually see percentages of the population per county as compared to just raw numbers. I'll click Counts and Amounts Colors and Style Options and divide by the total population, down a little bit more. And I'm also going to change the theme so that we emphasize the extreme. So now it seems that there are more people percentage-wise in the Bend area and in these middle counties who take asthma medication as compared to counties down near the coast. I'm happy with that. I'm going to click Done, save that layer style. So when I update my application, I'm going to see that new layer style pulled in. Great. So with Map Viewer, we were able to not only quickly load a web map with very little code, we were able to update the base map layer and also change the layer feature layer style to show a different visualization of the data that we have. Scene Viewer functions similarly to Map Viewer, the difference being that in Scene Viewer you can create web scenes to be used in custom applications, and you display data in 3D from feature services, vector tile services, and other services. Again, just like a web map, a web scene is a JSON object. For example, this is the LA Parks and Trails web scene again, and once more you see the operational or data layers and the parks and open space feature layer, which is this polygon, as well as other feature layers. If you scroll down, you'll see the spatial reference and the elevation layer and the base map layer. What I like about Scene Viewer is that there are certain features that I feel like you can visualize better as that you can visualize better in 3D as compared to 2D. For example, I have the same feature layers again, the current wildfires and like the current perimeters, but I also have thermal hotspots, which are these cones. And what I like about it is that it gives me a better understanding of the intensity of the fire radiative power. And when I turn on the smoke projection feature layer, I'll also be able to visualize how the smoke permeates through the wildfire and with relation to the topography of the area. So pulling in a web scene is similar to pulling in a web map. It doesn't take a lot of code. I will copy its item ID and put that in my application by referencing the web scene snippet. I'll place its item ID and save that so that when I refresh my application, I will get my web scene. And that's it. And in my scene, I can also always pan and zoom and play with the tilt as well. In the time I had, I went over 3 different tools. We went over the vector tile style editor, the map viewer, and scene viewer to not only create an item and access it, but also to perform data visualization. There are a bunch of resources I'd like to point out. There are some documentation for tools, content management, and visualization. There's also some useful videos about getting to know the new map viewer, customizing and styling your vector base maps, and best practices for designing web applications. I'm also linking the JavaScript API code snippets for Visual Studio Code because, at least for me, they cut down on the amount of code I have to write every time. And with that, I just want to say thank you, and please reach out to me if you have any questions.